Hello, Precalculus student. This video is for chapter 5.1 about angles. So we are going into a new area of study. We're looking at trigonometry function. What is a trig function? Trig function is special in that it gives us a function that can go periodical. So to begin with, we'll just look at the input of a trig functions, which or the way we design this trig function is with angles. Okay, so and we'll talk about the actual trig function in 5.2. So angles, everybody knows if you have some space between two lines, you have an angles, and we usually measure angle by degree. So but in order to create or to make a periodic function that goes up and down without flattening or go to infinity, we need a angle is in a special form. And also we want to expand the idea of an angle to negative angle and also angles that is more than 360. So let's go to the very beginning about defining what an angle is. In a real life, we would say, oh, I can draw an angle by, just draw two lines and then there is a vertex. And so the space between this, we'll look at how much degree it is out of 360 degrees. So that's how we describe angles in a common like geometry way, right? So that's how we say it. But we would introduce some terms. We call this is an angle if we have not lines but ray. So we have two ray. One is called the initial side, and the other is called the terminal side. They're both rays. And then the space between them, we would construct an angle with an arrow. So the reason why we have initial side and terminal side is the angle is done by having the terminal side start from the initial side and then turn. Okay, so you would create some space between them. The vertex where the two ray meet it's called a vertex. And the way we do it is so that we can label our angle as angle E. And usually by default, when we say an angle, we don't say that one that is outside, we say that one that is inside, okay? Or the one that's smaller in relatively speaking. You can also label an angle by saying three points, one on the one ray, the other on the other ray, and the middle in the vertex. So we can say this is angle DEF, or you can say this is angle FED, E being the vertex. Okay, there is a common way to describe the measure of an angle. Okay, so this is the angle. The angle is an entity, but the measure, like how many degree this angle span, is called the measure of an angle. And we can refer to it as variable. And instead of x, y, z, w to refer to this variable angle, we use theta, phi, alpha, beta, or gamma. So these are common Greek letters. And in this book, theta is used more commonly. So also in order to create the trig functions, that is a periodic function, we want angles to be oriented in a certain way, and we call that angles in standard positions. So this is an angle in space, 2D space or 3D space. But if we want to create an angle that can create a function, the angle needs to be in a standard position. We call it a standard position. And this is the way we can create positive angle and negative angles. So what happened would be we would put the initial side on the positive side of the x-axis, the vertex at the origin, and sometimes it's called pole. Okay, because later on you'll learn that the axis that we use instead of 1, 2, 3, we can also have some polar coordinate, and so the origin 0, 0 is also called pole. So the origin is where the vertex is, and the terminal side would be where would be on the space of this coordinate. And we would use a counterclockwise direction to refer to positive angle, clockwise direction to refer to negative angle. So negative angle of rotation means this angle is have a negative measure. But the rotation always starts from the initial side. So this is when we say angle in standard position. So and everybody knows the common way to measure an angle would be degree. That is this units. And one complete rotation is 360 degree. So if I draw 360, I will start with the initial side like this. And then I will draw my positive direction, go to counterclockwise direction, go back here. So this angle is 360, and you can see this is one complete revolution. A negative angle would be negative 360, would be still initial direction, and go back or go clockwise direction, and stop here. And this is, so whenever we draw an angle, you always have to have the arrow to show that whether it is positive or negative. It's still one revolution, but it's in negative direction, it's negative 360. And of course, because 360 can be divided into 4 parts, you will see that we have 90 degree right here. If the angle stop at here, so this is 180 degree. And we would have 270 degree. Now this picture show the degree number here, but usually we write the degree on the rotation or right at where the terminal side is. And so you can see that you can label the four the x-axis by 90 degree. So this, you know that this is where the terminal side will stop, 180 degree, 270 degree, and then this would be either 0 or 360 degree that way. Okay. So and if angles falls on the so we can also identify angles by where the terminal side stay. If the terminal side stay on the axis, it's called corantal angles. Corantal angles are the angles whose terminal side lies on an axis. If the terminal side lies on the first quadrant, we say this angle is in the first quadrant. Likewise, if the angles stop at the fourth quadrant, we'll say the angle, the terminal side stop in the fourth quadrant, we'll say that angle is in the fourth quadrant. Yeah, but the angle actually span all the way from the x-axis all the way there. So the typical question to practice the standard position is to sketch the angle in standard position using a sketch. So sketch 50. So what I usually do would be I mark the corantal angle, so I know the relative size of the angles where it should stop. 50 would be between 0 and 90, so and it is a little more or over 45. 45 is in the middle, so I'll sketch my terminal side like this, and then draw the arrow, and we'll say this is 50 degree. Okay, and it is in quadrant 1. 600 is more than 360. So how do I go about it? Oh, it must be I have done one complete revolution. So I would just imagine myself doing one complete revolution. So 600 minus 360 is 240. So you imagine yourself doing this. So this is the initial 0. And I would just do positive. Positive is counterclockwise. So go back here. Now I'm going to do the second revolution of 240. 240 would be between 180 and 270, right? So it would be around here, closer to 270, I guess. So you would go another round and stop here and draw your terminal side. So this is where the angle 600 is. So I write 600 here. Or you can write it here, and then it would say it is quadrant 3. Oh, by the way, I think I haven't talked about the numbering of the quadrant. This is 1, 2, 3, 4. It is also in counterclockwise direction. Negative 195. Negative means you go clockwise directions, so go down like this, right? So how do I know where they are? So I would say this is negative 90. This is negative 180. So negative 1, and then this would be negative 270, right? So if I go negative 195 would be around quadrant 2. So I put my arrow like that. That would be negative 195. It's in quadrant 2. Negative 810, that is a lot of negative rotating. So I don't know how much I would have to rotate. So, but I know that if I add 360, that is one negative rotation, right? But this is not between 0 to 360 yet, or 0 to negative 360. So I add another 360. So you just keep on adding until you are within 0 to 360. So that means negative 810 plus 720. That's negative 90, right? So you would know that, okay, we'll just do 2 rotation down, 1, 2, stop here. Okay, so that is negative 270. I'm going to do 90 more, so it'll be here. So negative 810. What quadrant is it? It is not in either quadrant, it's on the y-axis. It's a corontal angle. Okay, so that is sketching angles in standard position. The goal is to have angles that is positive and negative, and also greater than 360. The second topic is changing degree into radian. So we'll look at how we can, instead of using degree as to measure an angle, use radian. And I'll talk about it in the second video.